everyone. We would like to start the course with an introduction. And in this lecture, we will present the background and meaning of Six Sigma to get us started. The learning objectives of this session are to understand the origins of the Motorola Six Sigma methodology, list the 6 main themes of Six Sigma, and to just list the phases of the DMAIC process improvement cycle. We also want to understand the Six Sigma roadmap and the problem-solving strategy used in Six Sigma, which gives us our first equation. Y is a function of X, where Y indicates parameters that are critical to quality. They indicate the customer's expectations. And X indicates the influencers, the variables that can influence our critical to quality Ys. And what we're trying to do then is to establish the function Y is equal to the key influencing parameters, the vital few parameters that we can then control to improve our process. Now, since you're taking this course, most of you are probably already familiar with Six Sigma, and we want this course to support you either to refresh your knowledge or to prepare you for a green belt examination. But let's just step back and look at the big picture. The text, The Six Sigma Way by Panda, Neumann, and Kavanagh, explains how the customer-centric, improvement-driven Six Sigma approach achieved impressive benefits for companies such as General Electric and Motorola. The authors state that the Six Sigma system is a comprehensive and flexible system for achieving, sustaining, and maximizing business success. The Six Sigma process strives to achieve this by careful understanding of customer needs, use of facts through data collection and statistical analyses, and by managing, improving, and re-engineering productive as well as business processes to increase customer satisfaction and business excellence. And here by business excellence, we're talking about cost reduction, productivity improvement, growth of market share, customer retention, cycle time reduction, defect reduction, and a change to quality culture in new product and service development. So let's look a little bit at the origins and the development of Six Sigma. In the late 1970s, Motorola started experimenting with problem solving through statistical analysis and started using the Six Sigma approach in the 1980s to achieve one of its top corporate goals of improving quality. The engineer Bill Smith, called the father of Six Sigma, is widely credited with recognizing that a process mean, so the process centering, could not be maintained exactly on target, and that for complex products, the product variability had to be controlled to higher limits than was previously accepted. With Dr. Mikkel Harry, who was responsible for the development of the Six Sigma implementation strategy and deployment guidelines, Six Sigma was implemented at Motorola, and in 1990, Dr. Harry founded and directed Motorola's Six Sigma Research Institute. In 1987, though, it was the official birth of the Six Sigma methodology in Motorola, and this was for the communications sector. Used as an approach to track and compare performance against the customer requirements and to achieve an ambitious target of near perfect Six Sigma quality in the products produced. And what this means, and this is then key, is that the defect rate for the production of each component will not be more than 3.4 parts per million. This Six Sigma process, or systematic approach to process improvement to attain this Six Sigma quality, later spread throughout the company, with strong backing from the then chairman, Robert Galvin. Now, in the late 1980s, this process helped the company to achieve enormous improvements in quality, for example, tenfold improvement every 2 years, and a 100-fold improvement in every 4 years. And 2 years after they set out on their Six Sigma journey, they received the prestigious national award, the Malcolm Baldrige Award for Business Excellence in 1988. In the 10 years between 1987 and 1997, the company increased its sales 5-fold, saved $14 billion from Six Sigma projects, and saw its stock prices increase. All this happened to Motorola when it was facing tough competition from Japanese competitors. And several other companies have followed the Six Sigma process model and reported enormous successes. Two important ones are, of course, General Electric and Applied Signal or Honeywell. But what does this 3.4 parts per billion mean? And here we can look at this. This is exactly what we'll be learning in this course. And you're going to see this slide again when we look at process capability. But if you want to know now, 3.4 parts per million, we're roughly speaking about these tiny little tails here. We'll come back to that in a minute. That's actually 2 parts per billion, those little tails. But don't stop the video now. You will master this normal distribution. And this type of probability and statistics will stand you in good stead in many other areas, including business analytics and management and decision sciences. Let's look at a few terms from Six Sigma. First of all, the term sigma is used to designate the distribution or spread about the mean, the average of any process or procedure. For a process, the sigma capability, which we'll learn as the Z value, is a metric that indicates how well that process is performing. And we will, as I said, cover that in our lecture on process capability. The higher the sigma capability, the better the process. Sigma capability measures the capability of the process to produce defect-free outputs. And, as we'll learn, a defect is anything that results in customer dissatisfaction. We're defining it as a defect occurs during any process step when the outcome of the process step is not the expected outcome, and that means that we have defined the expected outcome in advance. So let's look now at the 6 main themes of Six Sigma. And again, this is from referenced in our textbook. The first major theme is focus on the customer. The Six Sigma process begins with the measurement of customer satisfaction on a dynamic basis. And Six Sigma improvements are then evaluated based on how they impact the customer and the customer wants and needs. First of all, the customer requirements are assessed, and then the performance of the organization's product is then evaluated against those requirements. Next, any unmet needs are addressed through product or process change. Customers get the highest priority in a Six Sigma organization. The second major theme is data and fact-driven management. The Six Sigma philosophy emphasizes the need for taking measurements, as you can see in this picture for the candle example. We're taking measurements on process performance, product performance, customer satisfaction. The Six Sigma process has no room for decisions that are based on opinions or assumptions or just gut feelings. Process managers and problem solvers should decide what information is needed and arrange to gather this information. The data should then be analyzed using the appropriate tools, and the information generated must be used to make decisions on process and product improvements. This is a closed-loop system in which measurements from the output are used to take corrective actions to improve a process and is a very important hallmark of the Six Sigma system. The third major theme is process focus. Every product or service is created or produced by a process, whether it is designing a product, for example, preparing an invoice or answering a customer complaint. Any of these situations, these activities can be mapped as a process involving a sequence of steps. for example. When processes are mapped using charts on paper, they can be better understood and analyzed, improved and managed. And so it's very important in Six Sigma to analyze a process fully. Then we are able to control it and improve it. And this is a key precept in the success of leading to the success of Six Sigma systems. The fourth theme is proactive management. Proactive management involves setting ambitious goals and clear priorities, reviewing them frequently and implementing changes in the system to prevent errors and defects from reaching the customer. So you can see here with proactive management in Six Sigma, you need to have top management focus and support. If you wait for customer complaints, then you put your organization in a firefighting mode. So proactive management also means actively preventing the problems from occurring. And it's a lot cheaper and less time-consuming than trying to solve them after they have occurred. The fifth theme is then boundaryless collaboration. And here, we need to have cross-functional teams with good communication among different functions in the design or production stages. And if you don't have this good communication, you have delays, redesigns, rework, all of which cause wasted resources. You need teamwork across the functions. You need common goals towards customer satisfaction. And this has enormous potential for creating savings and customer confidence. The Six Sigma approach emphasizes process improvement and process redesign through these cross-functional teams and creates an environment in which people work together and support one another. And finally, the last theme, the sixth theme, is the drive for perfection. And this is the most important theme of the Six Sigma process. We're driving toward near perfection, and that is, in our definition, not more than 3.4 defects per million opportunities. That we come to in a minute. DPMO, we'll see that in the next lectures. Not more than 3.4 defects per million opportunities in every process. This is achieved through diligent efforts in process analysis and process improvement, repeated iterations on a never-ending basis, we should say. And this is the way to satisfy and then finally delight the customers. And of course, the customer standards usually keep changing and becoming more stringent. There may be occasional failures when driving toward perfection, but a Six Sigma organization will not be deterred by these. They'll learn from their failures and make progress towards perfection. Again, quote from Panda, Newman, and Kavanagh.